Today I would like to show you how we can manufacture a fuel tank or a water tank for a ship using large-scale 3D printing, especially using our FlexCube 3D printer and our in-house developed material HDPE. HDPE is very suitable for fuel tanks and water tanks because it's completely inert to any chemicals. So here I have the design of a vessel, and below deck I want to have a custom made fuel tank. This is a 100 liter fuel tank. As you can see, a larger one would be an option as well, but I wanted to start with this 100 liter fuel tank because that would be enough for this size vessel. So I made this design, and I actually made it in SolidWorks this time. So here you can see the design I made in SolidWorks. Some of the features I made were some stiffening ribs. This will create a general, more stiff structure in general. I created some pockets where we can mount the fuel dop or the openings, fuel lines, weld those in. Fun fact, HDPE is a material you can weld as well. So after 3D printing, we can still weld parts to it if needed. So this is a design of a fuel tank. Right now I'm gonna show you how we can turn this design into a printable part using the Adaone for CEAD version. This is a version from Adaone which allows you to make programs for the FlexCube. In order to make sure the part becomes completely enclosed, I'm actually adding some design features like this to the part, because this gives us a starting position and an ending position we can cut off later. And this will ensure the fuel tank is completely watertight. We have no leaks. So the printing strategy will be a strategy where we're going to print at 45 degrees using the FlexCube. This will be our starting position, and this will be our ending position. These planes are fairly easy to cut off after we are done. So right now I will switch to the Adaone software to show you how the toolpath will look like. Here you can see the finished toolpath. It's positioned on the FlexCube 3D printer made by CEAD, and if we go through the toolpath you can see that it's printed at 45 degree angle using a single wall, and we have a starting position right on the platform, which we're going to cut off at a later stage. And this is actually a fairly easy print. Right now the printing time says about 11 hours. This has only to do with the layer time. If we would print multiple at once, it would still be 11 hours in total. So if we print, let's say 6 in one go, or 2 or 3 in one go, the printing time in total will still be 11 hours. Material use is about 24 kilograms. So let me now show you how I made this toolpath by starting from scratch. I'm gonna delete this toolpath. Yes. So when you import the file, you can import it over here. Then you can position it around anywhere on the print table. You can rotate it using these functions. And then once you found a good position on the print platform, you can move to the process itself. So we are using an additive process using our pellet extruder technology. We have our HDPE made by CEAD, and we're gonna print a 16mm surface. So this would mean that the walls on the two sides will actually be 16mm, but the walls on the top and the back, the front and the bottom, will be the angle 45 degree of 16 millimeters, which is cosinus 45, 11.3 millimeters. So maybe this is a little bit too much for a fuel tank. We could go for a thinner wall, but I'm gonna show you this printed part anyway. So the slicing itself is gonna be an angled slice. By using the set plane, we can set a 45 degree plane like this. The arrow is pointing the printing direction. Then we're gonna spiralize the layers so we don't have any layer change seam anywhere. And it's just gonna be one parameter. The movement is gonna be limited just by the layer time. Right now it's set to 200 seconds. For this speed we can actually lower this to 150 seconds per layer when we are using the 4 millimeter layer height and 16 layer width. So it's generated. So now the print time became 8 hours because we're printing faster. Material use is still the same. And this is the output. Now we're ready for printing. So I will show you the time lapse of the printed part.